So good morning, everyone. So today we are going to discuss a very important topic is how to download, you can say, sorry, how to process the SAR dataset. So we already showed you how to download the Sentinel-1 data, but how to process the Sentinel-1 SAR data inside your ArcGIS Pro. So that I didn't show you. So today I'm going to show you that process. It will be very interesting. See, after you downloaded the satellite image, you just kept in a certain folder and you export it. Okay, so then you will get this image of the shape files. Okay, so this file you need to give, you can directly open in ArcGIS Pro, so it is supported only, and it will also sit almost in the exact locations where it is actually belonging. Okay, so if you see here, I will go to this. Okay, so here this is the data. Okay, so mention the shape files. If you just simply click on OK, so this file will go and sit with the exact locations where it is actually belong. So this is the data uh, which is from the Bangalore. Okay, so let's see, let's how this data is actually coming up. Okay, so as you've seen, after I just open this file, so it will take few minutes time, but now it is perfectly generated that particular image file. Okay, now what I will do, I will just give a proper name to this particular file. I will rename it. Okay, so how to rename it? Just simply right click, go to the property. Okay, so I give this name as suppose Bangalore. This is Sentinel-1, so S1 underscore, this is a GRD product, GRD. Okay, so that I'm just giving and simply click on it. The next important thing is, if you want to process this SAR images, then the first important things which you required is, that is the image analysis license. So under the image analyst, okay, you just see here under geoprocessing, under the image analysis, you have the synthetic aperture radar tool. Okay, so under that, the first steps which you have to do, that is the downloading the orbit file. Okay, so what I will do, just I will double click on this downloading the orbit files, and I will going to give input of this SAR image. Okay, to downloading the orbit file. So see, what is the orbit file is actually, see, when we are preparing the SAR images analysis, it is actually an important steps to apply the orbit corrections. No matter how fine tuned you can say the satellite orbit may be, the locations of the satellites will actually drift it. So this could be due to the atmospheric drag or the solar winds. Okay, the earth is imperfect sphere, attribute to the non-uniform gravitational field or massive objects in the solar, okay, system. So that perturb the satellite orbit, okay, with their gravity actually. So because of this drift, the periodic adjustments are actually needed to keep the satellites on the track. So that's why we are actually doing these steps. So here you have to give your login credentials. So this is the same login credentials which I am going to use, so you can use it for your purpose also to process these data sets. Okay, so I'm just simply typing that GMSS. Okay, and the credentials of this also is same, GMSS GUEST. Okay, so this is the ID password you have to select, and then simply you can click on the run. So it will take a few minutes time to download the image. Okay, download this orbit file. So once it will done, we will go to the next step. Yeah, you see it is showing the downloading orbit file is actually completed. The next steps which we will going to apply, that is basically the apply orbit correction process. So this is the apply orbit correction process. If you see here, okay, so here also we are going to give the same data as an input. Okay, so because the orbit file already stored where the locations this data is actually there, so you just need to click on this. Okay, and see here automatically this orbit file will taken from there. So this is the extension of the orbit file. If you just see here, this is the shape files, this is a EPOF file, so that is basically your this EOF file. Okay, so that is basically orbit file which is already downloaded. Okay, now let's run this apply orbit correction process. Okay, so let's run and we wait for the results. See here, now it is actually applied. So orbit corrections is actually now done. The next steps which we're going to start, that is, you see, apply orbit correction is done. Okay. So once you this run this process, okay, so you will see the color image is actually render might look slightly altered, okay, but there has no much impact on the pixel values or the rest of the workflows, okay. So whatever process you run, if you want to save this project, so you can simply click on this save project. So whatever the steps I run, it will save. Now the next steps which we're going to run, that is the we were actually now going to start the SAR data processing. Okay, so first steps which we're going to do over here, that is the removal of the thermal noise. Okay, so first we will actually correct the backscattering disturbance, okay, caused by the thermal noise, which is input SAR data to orbit a more seamless images. Okay, so you will do that with the removal of the thermal noise tools, which is I'm going to show you now. Okay, so that is the removal of the thermal noise tool. Okay, that I'm going to use it now. The thermal noise is actually the instrument which is a noise is actually caused by the microscopic motions of the electrons due to the temperature, mostly from the internal you can say internal issues of the particular satellites. So thermal noise is actually mostly apparent in the area of the low backscatter value, such as the permanent water body we'll see, or in the oceans also we'll see. Okay, so let's give input of this particular data which I just run. So automatically orbit file, so I want to run over the both the polarizations, so I select the both the polarizations, okay, and then simply click on run. Okay, so let's wait for the results. Okay, see, now this is the file which is generated after pre-process these data sets. Okay, so you will actually examine the differences between the two SAR layer which you actually produced the before and after. Okay, so that you, if you want to see, so first you will actually applying the similar symbology for the both layer. Okay, so how we're going to do that? See here, we have this one. You can select this and then come to the raster layer, and you simply click on the symbology. Okay, so under the symbology, so here first things which you have to do, you have to convert it as a stretch value. So you can click on the stretch value. Okay, so see, this is the VV image will be there. So now first one I'm just going to take it as a VH. Okay, so this is the image. Okay, now you can change this gamma to 2, so to get better information. So see here, so I make the gamma as a 2 and I apply the standard emission of the stretch. Okay, now okay, so this is actually rendering to show the this pH polarizations band, which is actually enabled to clear the composite between this layer for the purpose of this tutorial. Okay, which I'm going to show you now. This gamma is actually a degree of means construct. Okay, so this increase the brightness actually in the on the image. Okay, so on the map, what is this Bangalore, this CNRF file which is actually clearly, which we are actually displaying now. Okay, now to comparing it, we can change this also as a stretch value. Okay, so if you see here, okay, so we have the same, you can go to the stretch value. Okay, and here also if you want, you can represent it in the same one, VH. Okay, so you can switch off this and you see now this is a VH. Okay, and if you want to compare with the same gamma value, so you can type 2. Okay, so this will be to compare this two image which we are actually produce. Okay, so this number of standard deviations, if you want, you can give to this also. Okay, so now if you compare these two image over the water body, then you will understand what is called thermal noise correction process. Okay, so if you see here under the water, you will see so many kind of white dots are coming, but after thermal noise removal, you see this is the image quality how it will be. Okay, so this is the way we have to understand what is the use of this thermal noise correction process which we just applied over the image. Okay, you can swipe it also if you want. You can swipe it and you can see this also. So suppose you to select it and you can see before and after changes what that particular area. Okay, so this is how it is helpful for us to understand that particular quality of the image. Now the next steps which we are going to do, so before that I'm just going to zoom to layer over the image. Okay, now uh, the next steps the next steps which we will going to do it now, the first thing is we are actually applying the calibration technique. Okay, so this is basically the applied radiometric calibration process, so that we will going to do it now. So next, this applied radiometric calibration tools is basically the calibrating the SAR data is actually necessary to obtain the meaningful backscattering that can be related to the physical properties of the feature in this particular image. Okay, so let's go to this go back to this panel. So go to the analysis toolbox and geopanel. Okay, so here you basically you see we have the tool basically that is applied radiometric calibration. So I can go with the applied radiometric calibrations, and now I'm going to give input of that CRF files. Okay, so this is TNR CRF file, so that I'm going to give as an input. Okay, so here also I'm going to run over these two bands. Okay, and I just want to create the beta node. Okay, so that I'm just going to select it. So you using the default as a beta node calibrations. Okay, so which will be required when you are actually later perform the radiometric terrain flattening. Okay, but if you want, you can go for the sigma node and gamma node, both informations will be also there. Okay, so now let's start to process this data. Okay, so this is all done. Okay, so the image is ready for first calibration process. Okay, so click on the run. So let's wait for the results. So after the processing, you will get the same image like this. Okay, so if you want to convert it as stretch values, okay, similarly you have to select the raster, go to the symbology and convert it in a stretch value. Okay, and see now you will get the value like this. Okay, so see, this is a 7491, like that you will get a value, but here this is for the VD. So if you want to compare with the VH, then click on the VH and see you will get the value something like this 76. So what it is doing, see here, the radiometric calibration process is actually transform the value range quite dramatically, because it is actually normalize the backscattering value. However, that didn't change the relative values between the pixels on the image. Okay, so uh, which is actually you can see swiping. If you are doing, you will not see the much differences between the before and after. You can see here, if I click on the swipe, you will not get that much differences over that. Okay, but just to brightness a few changes you will find it over here. Okay, so now the next process which we will going to do, that is radio means we will going to apply now radiometric terrain flattening. Okay, so basically we will try to do the radiometric terrain flattening process. So what is this? See, so now we will going to correct the input of the SAR data radiometric distortions due to the topographic using the applied radiometric terrain flattening tools. So due to the side looking nature of the SAR sensor, okay, so ground feature is actually facing the sensors appears which artificially brighter, and the feature is actually facing away from the sensor appear to artificially darker. So radiometric terrain flattening is actually normalize the backscattering value to eliminate these distortions. Okay, so to perform this radiometric terrain flattening, so you will need actually a DEM. Okay, so which I already downloaded. Okay, so it's a SRTM 20 TEMs, we are already downloaded it. So we'll provide this elevation data to about the extent over the SAR. Okay, the project we will actually download that contains DEM layer which we will have added to this particular map. Okay, so let's see how we are going to use that process. Okay, so this is the applied terrain flattening, so applied radiometric terrain flattening process. Okay, so this is the process. So we need to give input this particular data sets. Okay, so I'm just going to apply that. So before that, if you want, you can add a 90-meter DEM which I already have here. Okay, so I just going to add the DEM. Let's see, where is the DEM? Is there? Oh, this is the DEM which I have with this. So let's see how much is. This is the area of that particular DEM which I just downloaded. I can take a larger area, but it's fine. Okay, so because my concentration is over the Bangalore. Now, if you want to put a color, you can give a color also. Yeah, you can change the color also. Okay, so now if you want to take it in back of this particular city, so that I can put it. Okay, so let's run this and then get an idea about how it will coming. Okay, so we are going to apply now the terrain radiometric flattening technique. So whatever the area we're going to apply the radium, so that much area only it will go to run. So radiometric terrain flattening, you can go to this input, the CNRF file, calibration file that you have to give input. Okay, so this is the output file will automatic generated. Okay, and this is the DEM raster, so you can select the output as attribute. Okay, so I need to apply it over the board. So I applied geoid corrections. If you want, you can check on this to check this box on. And if you want to apply this over the both polarizations, then say I want the both polarizations only, and I'm going to use the gamma naught. Okay, so if you want sigma naught, so you can go for it. Okay, so let's run it and let's see DEM is actually, there is actually resolutions which will be 90 meter pixels, which is sufficient to follow the workflow. Okay, so let's see, let's how the results is coming. Let's see. Let's run it and we will wait for the result. Okay, so this is the results which came. Okay, so now we can convert it as same in a stage value. See, whatever the DEM area we provide, so accordingly it is actually generated. Okay, so now it's a way of the subsetting, you can also tell. Okay, okay, anyway, I will just make it as a symbology. Okay, so we can convert same the stage value over the VH. Okay, so we can convert it over that. So may you will not exactly understand if I am not switching off this, because it is take time to open the data. So it is came actually. Okay, so it will actually taking a time to upload that particular, see here. Okay, so as of now it is came. So here if you want to adjust it the same way, okay, so that you can do it here. Okay, like primary symbology we are doing. Okay, so if you want to make it more brighter, then you can go with the gamma, so that it can increasing too. Okay, so then it will be little clear image will come. And HV over the HV polarization only I'm just going to apply that same technique. Okay, see here now this output is actually coming. Now the next process which we will going to apply this over image, that is basically the displacing the despickle the imagery. Okay, so next we will do the correct this input SAR data for the speckle by using the despickle tool. The speckle refers is actually to granary and salt. Okay, we usually call it as a salt and pepper effect that we will going to do. So then can be seen through the SAR image. Okay, so backscattering recorded is a single pixels is actually result of the radar wave interacting with the multiple features of the objects and within the pixels on the ground, also ground sets. So when those interactions and interface is actually constitutively, they are actually from the bright pixels actually. So when they are actually interface the destructively actually, so they actually form the dark pixels during that time. So shade of this gray corresponds to this interface, and they are neither fully constructive or not destructive. So for that we require to perform this pickle correction technique. So this is kind of filtering actually. It's very easy to understand. Okay, so now I'm just going to apply this. So I will go see here this. So for this I'm just by default apply this refined filter, remindly filter, but you see frost and all the filters we already have it here. Okay, so I didn't change anything, so let's run it and let's wait for the results. So as you've seen, this is the file which is actually generated. Okay, and same way you can convert it also, and you can check like how what is the changes in before and after filter, how it is applied. Okay, so you can go to the stage value and you can change it to the VH, and this is the results you can find the before and after. You can go to the swipe See how this is actually changed, okay, over the before and after image. So some smoothness is actually came over the image, which you see in a down one, which is so many noise will be there, so that will be reduced because paper salt and paper noise is actually removed from this particular image. Okay, now the next important steps which we have to do, then we have to go back to this tools. Okay, and here now we are going to do the applying geometric terrain corrections. Okay, so this is earlier in the workflow also, so we are actually use the dam layer to correct the radiometric distortions. So now you will use this dam layer again, this to the time or to correct for the geometric distortions and rectifically the input SAR data. So authentication process of the correction is actually apparent to the change in the positions on the ground objects caused by the perspective of the sensor view angle and the ground terrains. Okay, so we will actually now perform the authentications with the applied geometric terrain correction tool. Applied geometric terrain correction tool. This tool we are going to use. Need to give input of the DSPK file, the same DSPK file which you are going to use. Now I want the both and the same name, you can give it here as a, okay, so you can click on this apply geoid corrections and then simply you can run. So let's wait for the results and let you know. Okay, so this is the now after geometry corrections this image will came. Okay, so you can go and create the same kind of symbology. You can change like symbology, you can change it as a stretch value. So what the VH we want to see. Okay, and to increase this you can increase the gamma. Okay, so that you will get a better view. Okay, so that is the thing which you can do, and you can check this output also. Okay, so that is the easiest way to pre-process this image. So how we'll know that the geometry correction process is right? Okay, so for that the easiest way is if you zoom certain area. Okay, so if you see this is the some kind of a road which is visible. Okay, so now it should visible in your base map. You see exactly it was matched with this, and if you want to more confirmations you can open the hybrid layer also. Okay, so for your better understanding, see from this map. Okay, so if you go with the base map and you find the image hybrid, so then you will get all the informations from this. And see, this is the what the railway parallel pipe road, so that is actually coming very nicely over this particular area. Okay, so this is the way you can identifying that your geometry correction is actually done. Okay, so the next steps which we will going to do, that is the you can convert it to the SAR unit. Okay, so next we will actually convert it to the convert to scaling of the SAR data between the linear to the decibels. Okay, so to converting unit using this particular the SAR unit tools. Okay, so because of this dB, this is actually logarithmic unit. Okay, so it is actually convenient way to manipulating and visualizing the large number of large dynamic ranges. Okay, so to converting these units to the dB, we'll actually simply we will show you this SAR image interpretations to improve this actually display, as it will reduce the range of the amplitude or the intensity values. So after this conversions to this positive value, so we will actually represent the backscatter towards the sensors, or the negative values represent the backscatter from the sensors. Okay, so let's see how we'll do that. So simply go to this toolbox and we can use this convert to SAR units. So I will give input of this last file. Okay, so I'm just going to convert it from the linear to dB. Okay, so let's run this and let's see the results. Okay, so this is the results. So there's a nice results which came over this particular image, as you've seen. Okay, so you see this output if you go in a properties now, so whatever the steps you are actually applied. Okay, if you want to see, so under the source you can see the raster informations. Okay, so you will get the raster information, and this is a processing history how it is created. So all the steps is actually mentioned what we are actually applied. Okay, so from this also you will get a lot of informations. Now the last thing which we're going to create, that is the SAR composite. Okay, so creating the color composite. So we will create the color composite of this image using the create color composite tool, which is there already here. So as you see this earlier, that our this SAR images is actually composed with the two polarization bands, okay, HH and HV. So when we will actually, we can view the each band independently, and combining them we will create the richer view of this particular landscapes, which will allow you to distinguish more clearly the surface characteristics such as the water, land and urban structure. Okay, so we will do that by creating the color composite in which each band will be assigned to the red, green and the blue display channels. Okay, so creating this color composite, we will result the image where the ground features can be identifying based on the colors. Okay, so let's run it. So I will go back to the tool, and here we have the clear create color composite. So you need to just give input of this. Okay, so this is the band combination. So whatever the band combinations you want, so you can give it here. So here under this B1 you just need to type it here like this, like HH, this one is HV, and if you want this as a difference image, then you can go with HH slash or you can say HH minus HV. This is a differences image. If you want, you can create a ratio image also. So for the flood I usually use the ratio image. Okay, so because of this original image has two bands, HH and HV, so there is not a third band, so we are going to create the blue expressions, okay, to this particular image. So instead of to, you actually populated it with the math formula using this HH and HV. So that means that for the each pixels in this image which is value having HV, okay, band will be subtracted from the value with the HH. Okay, so the results will be act as a third band which will actually display the blue channel, which will be further highlighted inside of the features of the landscape. So let's see how it is looking like. So let's wait for the, okay, so it is coming wrong because I didn't change this method. So here I have to give this as a band name. So once you give the band name, then only it is possible to run. Okay, so let's run and wait for the results. Okay, so I given that name was wrong. So you see here, once I select the band name, so automatically the band names will come like this. Okay, and here from here, if you want to create your own band composite, you can create like a VV minus VH also you can do. Okay, so I will make it a default. Let's run it and see the result first. So let's wait for the results and see. Finally we will get this results as that composite. Okay, so we are already created one composite. Okay, so now I'm going to create one more composite, which is differences of these two bands. Okay, so let's see how it is also looking. Let's wait for the results. Here is the results. So this is also interesting. See here, different composite. Why I'm showing these two band combinations means one is the differences image, another one is the you can say this is the this is basically the ratio image, and this is basically the differences image. Okay, so different polarization you will going to use, and then you will get a different results, which you need to do the interpretations properly. You have to interpret it. Okay, so you see the radar images, how nicely all the lakes inside the Bangalore is very nicely highlighted. Okay, so this is the all the way we are processing the SAR images inside ArcGIS Pro. Okay, so thanks to Elizabeth, who is actually helping us to showing us how we are actually going to do the pre-processing over the SAR data. So thank you everyone. So if you like this video, please subscribe the channel and share this video to the others. Thank you all.